Okay, so in this particular problem, a tomato plant grows taller at a steady pace. That is C. That's this one here. Quickly at first, constant, and then steady pace. That's B. And then finally, slow pace, then quick pace. That's A. On number 4, it starts at 15 and decreases by $3 each time. It is discrete because you cannot do half of a movie, so you can't do half of one, so you can't fit in between those points. Okay, a possible situation. As the age increases, the weight increases at a quick pace. You could be very young here. And then as you get older, the weight increases slightly, so at a steady pace, and then it's constant as you're older. Here, each package is going to weigh about 10 pounds, so there it's discrete data. Now, on this section, express each relation as a table, graph, and a mapping. Alright, basically, I put all my x's in this column, all my y's in this column. The only thing you have to do is list them. Then, I graph them. Remember, you start with 0, 0. You go your x's first, so I went left 5, up 3. Left 2, up 1. And I continue that trend with the rest of them. On the second one, I did the same thing, and you can just see how I plotted them and did the mapping as well. Okay, on this problem, I listed the domain here, listed the range here. It's all these numbers and these numbers. Notice it's not a function because the 2 repeats. On number 4, the domain is from here to here, therefore x is between 0 and 3. It's greater than or equal to 3, but less, or greater than or equal to 0, but less than or equal to 3. The range is the y values, so if you look at the y values, it goes from 1 to 4, and we're talking about this part right here. Therefore, y is greater than 1 or equal to, or less than 4 or equal to, and it is a function because it passes the vertical line test. On number 5, you list the domain. That's all these numbers here, but do it in order. Again, on the range, you only have to list the 4, the 6, and the 8 because this 6 and 8 repeat. And both of these are functions because it passes the vertical line test and has only one x for every y. Okay, in this page, we're looking for the slope. And remember, on both of these equations, we want a relationship between the x and y values. So remember, it's rise over run, or some people like to say it is the change in y over the change in x. And that's what we're going to do. We're going to look at those two things. All right? Let me erase this right quick. All right, so now, notice that the y's here are increasing by 1. The x's are increasing by 1. Therefore, you have a slope of 1 over 1, which is 1. Well, y equals 1x. So instead of mx plus b, there's your, just like saying y equals mx plus b, there's my slope, so 1x. Now I just got to find the y-intercept. Well, if I continue this, negative 1 and then finally to 0, well, since these are also increasing by 1, the next number would be 3, so my y-intercept would be 3, so your b value would be 3, and there's the equation of that line. Same thing with the next one over here. It increases by 2 for the y values, so that's 2. So that your rise is 2, your run is an increase of 1. So therefore your slope is 2 over 1, which is 2. So y is equal to 2x. Now I got to find the y-intercept. Well, that's easy to do, so now I'm going to work backwards. So with this, since my x is going this way, 2, 3, 4, I'm going to go backwards. 2, 1, 0. So when x is 0, do the same thing with the y's. 5 to 3, 3 to 1, 1 to negative 1. So when x is 0, y is negative 1, and there's my equation. Okay, the independent variable and dependent variables. Ice cream sales increase when the temperature increases. So the temperature is the independent, and the sales, the ice cream sales, depend on the temperature. Number 4, the independent is the dependent is the cost of the party, and it depends on the number of people. And then on this one, the cost per charges, so this would be like y equals $7 per hour. If you want to put it as a function, the amount Carson makes, or his profit, is a function of the number of hours. And then K donates twice as Ed, so K is equal to 2 times what Ed makes. So if you want to make that a function, K is a function of Ed. Okay, this next section should be pretty easy. Only thing we're doing is evaluating each function. Now, when it says to evaluate, we're going to plug in. So this 2 will plug in for this x here. And this -6 will plug in for this x here. Now, the way you write it is, notice it's f of 2. I plug the 2 in for x, so 5 times 2 is 10, plus 1 is 11. Therefore, when x is 2, y is 11. Same thing with the 3. This is 15 plus 1, which is 16. So when x is 3, y is 16. I guess input and output values. On g of -6, that turns out to be a positive 24. -4 times 2 is a -8. There's your coordinate points. Down here on h of 3, well, I'm going to plug in 3. 3 minus 3 is 0, so therefore at 3 is 0. And then 1 minus 3 is a -2, therefore 1, -2. Okay, in this particular problem, we want to write a function rule to describe the total cost of the class and find a reasonable domain and range. Well, we know that it's going to cost $15 up front, so that's your plus 15. That's your initial fee. Then it's going to cost for each class $10 per class. Now, you want a reasonable domain and range? Well, you know that your domain is going to be, you can go 0 weeks, 0 classes, because it's between, you're going to go once a week for 6 weeks. Well, you can either choose to go 0 or 6 weeks. So 0, 1, 2, 3, 4, or 5, or 6. Those are the available possibilities. You can't go half a class. Your range, if you go 0 times, you plug in that 0 right there. 10 times 0 is 0, plus 15 is $15. And then it would increase 10 times. So 25, 35, 45, 55, 65, up to $75. And that would be your possible ranges. On this particular section, I basically put in, this is the domain we have. Let me get that right there. This is the domain. I put the x's right here. I then plugged it into the equation and got the y values, thus giving me these coordinate points. So now I'm going to plot those points. I also labeled them, and then I connected them. On the second one, notice it has a division. It's kind of tricky because it looks like a subtraction if you don't look close enough. But in this case, it's y is equal to x squared plus 2, or sorry, divided by 2, and that's what I did. I plugged in the x's in my domain, plugged in the x's into the equation, divided everything by 2, and came out with a y value. And notice it gave me the shape of a parabola. In this particular problem, we're talking about a salmon swimming. So I just kind of started at 0, and I went from 0, 2, 3, 4, and 5. Notice I skipped the number 1. But when I plot those into this equation, when I plug them in for x, 8 times 0 is 0, so therefore I get 0, 0. And so on and so forth. I get 2 and 16, so 0, 0, 2 and 16. 2 and 16 is right there, 3 and 24, 4 and 32, and 5 and 40. I created a line right there. And when I tested at 3.5 hours, that comes up to about, something around 26 to 27 miles. This problem is exactly like the salmon problem that we just got through doing. I did the same thing. I graphed the coordinate points, and on this one, because it was a little clearer, I did a line straight up, and notice it was more accurate, so it was about 28 miles on this one. Okay, on these last two problems, the graph shows the relationship between the cost of an item and the sales tax due. Which function is graphed below? Well, I kind of gave you a little hint here. So notice on a graph, I like to use rise of run. Well, the rise was $3, and the run went from 0 to 50. All right, and the way I knew that is because I picked a point. If you notice right here, it crosses that intersection right there, and it started at 0, 0. So I felt pretty safe using those two coordinate points. So I went, like I said, I went up 3 and to the right 50. So 3 divided by 50, if you actually put that over 100 and made that 6 over 100, that is actually 0.06. So if you notice anything right here, that one looks just like what I was looking for. 1/6 is not 0.06. You can't have x in the denominator, and 6 times x would increase a rise of 6 and a run of 1. So the only one that's feasible is B. On number 5, notice the graph comes this way at an angle, so it's not really linear. Well, I can eliminate G because the x value has an exponent of 1, or J because it has an exponent of 1, and F has an exponent of 1. So because there's that slight curve, I know it's not linear, and the only one that's not linear is this one.